One is going to be a little bit more challenging. It's going to tie together a couple of topics, a past topic and one of our new topics. And specifically, it looks like we're going to try to find the derivative of this. We're going to need to know the quotient rule, because I've got this divided by this. But also, at some point in the quotient rule, I'm going to have to take the derivative of the numerator, so we need to have memorized our derivative of our inverse tangent functions. So pulling both those together at the same time. Easier to do independently, a little bit harder to do both skills at once. So to take the derivative using the quotient rule, it would say take the derivative of the numerator. And if I took the derivative of the numerator and use this as a guide, it would be 1 over the square root of 1 minus x squared, except we're plugging in 3x instead of x, so this would be 3x times 3x, which would be 9x squared. And we have to worry about the chain rule, so the derivative of 3x would be 3, so multiply all of that by 3. So there's the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator, all over the denominator squared. And this one looks really messy, but there's not going to be all that much that we can do here. Let's see, we could... Well, let's go ahead and do 3 times x, and let's just call this 3x. And multiplying this by 1 is going to just keep that the same. We could look at this as a complex fraction. If you notice, we've got a smaller fraction here within a bigger fraction. So I could make this smaller fraction go away if I was to multiply it by its denominator, because that makes those cancel out. But to do that, we would then need to multiply every term by the same thing, which is fine. But that gives us 3x minus, we've got this times this, all over x squared times that. Still pretty messy looking, but at least it's not a complex fraction now. So nothing else needs to be done here.